Hello everyone, welcome to the lecture series of environmental changes. Today our topic is water scarcity. Now let's look at the irrigated area of US. This slide shows how the irrigated area has been changed over time in the US. The map in the left slide shows the total irrigated area of US on 2010, and if you want to see the progression or the change in irrigated area over 20 years, past 20 years, you need to take a closer look into these two maps on the right. These maps are created based on the USGS data as it collects and compiles national water use data by county every 5 years, as I mentioned earlier. They also estimate the irrigated area. In the period of 1990 to 2000, irrigated area has been increased in both sides of the US, majority in the eastern side. Irrigated area has been increased a lot in the eastern US during the period of 2000 to 2010, and there is no more increase in irrigated area in the west side of US. Irrigation water is applied in the more humid eastern states to supplement precipitation during critical period of growing season. It increases yields of crops and in some cases the number of plantings. Investment in irrigation equipment is a significant expense, and once farmers install irrigation equipment, it is not likely that they will not irrigate their crop, even in the case of inefficient irrigation system. Therefore, over a lifetime of an irrigation system, irrigation water demand is significant, although varying with changes in year-to-year weather. Surface water, groundwater, or a combination of both are the source of water applied in irrigation systems. However, in these days, groundwater withdrawals are more. Overall, most of the states in the upper Mississippi River Basin have increased groundwater use for irrigation compared to surface water in recent years. Expansion of irrigation practice in the eastern US has the potential to stress rivers and drain aquifers. One of the main reasons of increasing use of groundwater in eastern US would be the groundwater rights, which primarily used in the Midwest and eastern US, and they are fundamentally different than those in the western US. So historically, groundwater was not the primary focus in US water doctrine, and water doctrines were mainly designed for surface water use. A common set rules for ground and surface water is very challenging to establish due to the availability of water and its site-specific geology. As you can see in the map, riparian loss permits unlimited water withdrawals of the water by riparian property owners, and these are followed in mainly eastern states. In appropriation system, which are mainly followed in the western states, here the rights to withdraw water are separated from property ownership. Different components have been added into these two basic laws, such as water users have a time-limited permit and they cannot extract water more than their proportion of property ownership. So part of my research is to identify groundwater rights in US and to improve understanding of the relationship between groundwater rights and groundwater withdrawals, so the water managers can make more informed decisions regarding how policy choice will influence groundwater withdrawals in time of stress. Through a review of the available literature, the 48 contiguous United States have been classified into 4 categories based on the dominant rights of stakeholders to access groundwater. And there are prior appropriations, where the right to groundwater is based on the timing of the appropriations to access water. That means first come, first serve. Correlative rights. The main features of this right is that each user has a right to the groundwater in proportion to their overlying land ownership or other allocation mechanisms, regardless of the timing of their first appropriation. Reasonable use. Water users must obtain a permit based upon an evaluation of the reasonableness of the recommended beneficial use. And number 4, absolute ownership. Landowners can withdraw groundwater from their overlying land at any rate without advance consideration of impacts to the adjoining properties. This US map is showing all the states with their assigned groundwater rights with the different shades of green. Most of the western states follows the prior appropriation as a PA, and most of the states in the eastern side they are following reasonable use as noted RU. And you see that Indiana is following the absolute ownership, which is AO, and some other states, Texas, Louisiana, Georgia, Maine, New Hampshire, Massachusetts. In California, they are using CR, along with Iowa and Minnesota. This slide shows how the groundwater rights influence on groundwater withdrawals. Analysis of covariance and coverage has been performed to understand the influence of groundwater rights on the dependence of irrigation variables, which include precipitation, runoff, and temperature. In these slides, only one example has been shown, that is runoff in the x-axis, and groundwater withdrawal has been used in the y-axis. So, analysis of covariance shows groundwater withdrawals depends on water availability, but the direction and the rate of dependency is modulated by water rights. AO is most responsive with the change of the temperature and precipitation, as the landowner has the ownership on their own water and they can use it whenever it was needed. The PA is also shows a strong result in an opposite order, which means PA did not influence as their water use was maintained by first come, first serve. Okay. A non-parametric Mann-Kendall test with sand slope estimator. So this slide shows the trends in irrigation rate for different water rights. So the PA, it followed by 13 states, and 3 of the states are showing positive slopes, which means increase in irrigation rate. In case of RU, 15 states out of 22 states, the irrigation rate has been increased. For CR, which means the correlative rights, 2 states out of 7 states, they are showing the increase in irrigation rate. And for absolute ownership, 4 out of 6 has also been increased their irrigation rate for the last couple of years. That means the irrigation rate has been changed over the years for most of the water rights. Was done to determine statistical significance and direction of any correlation between fraction of irrigation from groundwater, total irrigation volume, total irrigation rate, and irrigated area with time. The significance level was 0.1. In this presentation, only one. In most previous analysis of water scarcity, groundwater storage has been neglected, and limitations on future groundwater storage has typically not been quantified in analysis of future water resources sustainability. Including groundwater storage is more appropriate when calculating water scarcity indices. Based on all the analysis, the take-home messages are: irrigated agriculture dominates water withdrawals along the lower Mississippi River Basin and the majority of the western U.S., resulting in unsustainable water use. The western U.S. is experiencing high stress for both groundwater and surface water stress index. Water stewardship will be vitally important in future. In most of the cases, groundwater recharge is localized, and the process is highly variable and not fast enough to replenish the extracted water, which makes the groundwater resource more susceptible. Groundwater doctrines used primarily in the East were not designed to protect vulnerable groundwater resource. In this situation, a thoughtful, science-based policy could be a key part of identifying the most sustainable solution. However, doctrines are very different in defining groundwater, and the legal definition is often different from the scientific point of view. Local knowledge of groundwater hydrology is needed to establish effective policy, but on the other hand, creating policy at the local level makes regional scale integrated water resource management very difficult. Factor, which is water scarcity, is increasing day by day. Besides water use in agriculture and the groundwater policy, irrigation rate has been used, for example. And as you can see, um, 13 states are following PA, and among them, 3 are showing increasing irrigation rate with time. RU, 22 states are following RU, and among them, 15 states increased the irrigation rate with time. But 2 states are increasing the irrigation rate, and in case of